Hi everyone, I'm Andrew Turner with Good Space High Performance Builders. We are at the pre-demo stage of our Sacramento Passive House project. Today we're going to be testing the air leakage on this house, and I'm joined by Dave Barnes, who's going to do the blower door testing. We're super excited about this project. It's our Sacramento Passive House project, and as far as we know, it's the first certified passive house in Sacramento, so we're excited to share it with you all. So we're right here at pre-demolition stage, and what we're looking to do today is test the air leakage. Because this is a certified passive house, the building envelope air leakage is very important. We want to control that and create a really good environment. We will have really good ventilation, but we'll get into that in future videos. So right now, we're going to test what this house is. It was built in 1942, so probably fairly leaky. However, the homeowners have been here for a while and pretty concerned with creating a good indoor environment, so they had done a lot of air sealing themselves. So we'll be curious to see where that comes in. So to help us with the testing, we've got our friend Dave Barnes here, who's going to do a blower door test. Welcome, Dave.
Thank you.
Yeah, so Dave's BPI certified, does blower door tests, diagnostics, energy auditing, HVAC calculations, and design. So really good experience there, and he'll be able to show us what we're going to do.
All right, so we have the blower door tester, which is this equipment right here. It's always set up in an exterior doorway. We've got the frame and panel, and then we've got the fan assembly there. The fan assembly will either pressurize the house or depressurize the house to a preset number, and then will give us a CFM of airflow leakage number. And that can be used for other formulas to determine certain things. And I use it on my load calculation formulas for HVAC. This house is going to be interesting because, yeah, they've done some air sealing. It's an older house, but they've done air sealing over the years, so it'll be interesting to see where it's at right now. And then as we run the fan, from inside, we can actually use the fan to find some of the air leakage that's there, so it's kind of a good diagnostic tool besides giving us a number. And then it's always good to do a before and after test when you're checking and sealing for air leakage.
Awesome. Well, let's go inside, turn it on, and see what we got.
Sounds good.
We're joined by the homeowner, Leith Eunice, today. Thanks for coming.
Definitely glad to be here.
Leith's going to show you around and show you the air sealing he did prior to us starting on this project.
All right, so for in here, what we did was we sealed all the light fixtures because with a smoke pen, I was able to identify that there was a lot of leakage. We went through the entire house. We also found that the fireplace was very leaky. The louver did not close completely, so we sealed that. The integrated mailbox over by the blower door, we filled that in so that way it wouldn't have any draft coming through. And then behind all the outlets, we put a coverage plate so that way any airflow from the wall in would be minimized. And we think what happened was that this side of the house settled a little bit because that ceiling picture rail was very leaky with the smoke pen, so much so that I just went the whole length with caulking. And we also noticed drafts coming through where the wall meets the floor in several places, but this room was the worst.
We're inside now. You can see the other side of the blower door. So we're going to get this started. Dave, can you explain what we've got here?
All right, so we've got the panel, the fan. There's some interchangeable rings that are based on how leaky the house might be. And then we have This digital manometer right here, which is going to give us the measurements that the blower door is seeing. It's got a port for measuring pressure differences from indoors to outdoors, and it's going to achieve a target
That's
pressure.
this line here. It goes to the exterior.
Yeah.
Okay.
And then we have another one that's measuring flow through the fan assembly, and that's going to give us a flow measurement in CFM.
Okay. Should we fire it up?
Yep, sounds good.
Let's do it.
So I'm going to program it to achieve 50 pascals of pressure differential, which is the industry standard. And it's going to ramp itself up. It's all self-controlled. It's going to ramp itself up until it achieves 50 pascals of pressure, and it's going to give us a measurement in CFM on the screen.
And you've already determined that that's the right size ring. You kind of did a pre-test.
Yeah.
Okay.
Right now, it's already stabilized, and it's giving us a measurement. This one you can see is about 1,070, 1,080 CFM, and the top number is the negative 50 pascals, or very close to it.
And you've already closed off all the openings in the house, like the fireplace.
Yeah,
And,
that's a very important step, is to make sure all the exterior windows, doors, any openings to outside are all closed off. And then making sure all the bedroom doors, closet doors, anything interior is open to the blower door fan, so it can see leakage throughout the house.
So we're at a point now to use this information to work out our air changes per hour.
Yeah.
And then see what that is.
Mhm.
And we're about to compare that to what we need to achieve for certified passive house.
Yes.
Okay, let's do it.
All right.
Okay, so we got the results, calculated it, the CFM versus the volume of air, did the calculations. Dave had to run to another job, so I'm going to finish it up, but we have 9.5 air changes per hour based on the CFMs that we had at 50 pascals. And the passive house standard that we're going to be building this Sacramento passive house to is 0.6 air changes per hour or less. So right now this house is 15.5 times more leaky than the standard that we're going to be building this to. So quite a difference there. So I guess one thing to talk about is why air tightness is important. Well, part of it is to do with the heating and cooling, thermal comfort that we think about. So the air sealing is important because if the air is leaking in and out of the envelope of the structure, any of that air that's been heated or cooled, once it escapes from the building, that's being replaced by other air that's not conditioned that you have to pay to heat and cool. So that one's often overlooked. Another big one for us really is health. We have wildfire smoke here. We have allergies, pollens coming in, exhaust smoke from vehicles and other pollutants that people are spraying outside. So there's all sorts of outdoor bad contaminants that we don't necessarily want to come in. So we want to control that airspace from keep the outdoors out and the indoors in. And then the fresh air we do bring in, we'll be bringing it in and filtering it to keep it clean. And heat exchange, so we don't have an energy hit. And we'll get more into that later. There's some other things that are also really great. There's the durability factor. So if you're bringing air through the envelope, it could be coming from the crawl space, outdoors, attic, and if it's pulling moist air through, it can put moisture into the structure and cause decay, rot, mold, undesirables like that. Another one that people really enjoy is the fact that you keep a lot of bugs out, right? So if we're air sealing the little gaps, and there's nowhere for bugs and critters to come through. Also, keeps your house cleaner. You have less dust, less dirt that's getting in. And another one is quietness. A lot of sound travels through air. So there's an air gap, the sound's coming through there. If you seal the air gap up, that stops a lot of the sound. So all those things, really good reasons for air sealing the house. So now we're going to show you a few tools that we can use to check for air leakage. So in this house, we're just going to show it, what we can use for a retrofit. We'll kind of use these things, and we'll use it as we build out the passive house, but really good identifying. So we're going to use a combination. We'll have the blower door turned on, so we'll have 50 pascals pressure on the house, and then we'll use IR camera so we can see differentials. So right now it's a bit cooler inside and hotter outside, so we'll see that. We've got smoke pens and some other things, so we're going to give you a tour. Okay, we've got the infrared camera here. It's got a screen here that you'll get to see. We're going to show you a few spots we identified just in this room here. So I'm going to turn around. We've got a couple of things. There's a electrical outlet, and it's leaking a good amount of air. We've got 96 reading there, and then the wall adjacent, 84. So it's definitely a fairly hot day here. Then as we go down to the floor, this joint, we're going from carpet to wall, so we've got definitely some leakage right there at that seam. And then I'm going to rotate around. That's just some sunlight on the floor. But up here, we've got a beam. We can see some cracking there, and there's a good amount of heat following that crack in from the beam to the drywall. And maybe there's a thermal issue there too, perhaps. And we're going to walk over to one more spot that's quite interesting. It's the whole house fan, which can be good in some houses some of the time, but in a passive house, they're not great. But you can see there's just a ton of heat coming in there, even though it's got a damper there. It's pretty leaky. So good tool. We've got the fan, the blower door running, so that's giving us that pressure differential that's allowing us to see these temperatures as the air is moving. We've got another testing device here. We've still got the blower door running, the smoke pan, so we can get a visual of air movement. This one's kind of interesting. You can probably see the smoke, but it might be a little hard on the video. But when we bring it down by this receptacle, you can actually see the red just firing up there with all that air blowing through there and all the smoke coming off. Pretty good indicator of what's happening there. Well, that was great showing you guys the tools we can use to find the leaks. We'll mostly use those in a retrofit situation where we want to find the leaks and seal them with tapes or caulks or other methods. So it's a really powerful way of finding them to get that number down. Just to recap, we had air changes of 9.5 air changes per hour on this house, and the homeowners had already done some work to try and get that down. With passive house, we have to be under 0.6, so it's going to be a big difference. We're able to do that more easily. We won't have to do as much testing. We will do periodic, but we'll be going after the really small holes. We'll do a lot of planning to get it airtight from the beginning, from design through construction and at the end. So we'll be doing a periodic test. So yeah, thanks for watching, and keep following along as we build this Sacramento passive house. Cheers.